Welcome to this Maths Made Easy video on the chain rule. And to start with, let's just take a look here at adapting to dx by dy. So if we have equations of the form x equals f of y, then we can calculate dx by dy in the same way as usual. If we simplify its reciprocal, then we find an expression for dy by dx. However, we could also couple this with integration to find y equals f inverse of x. However, we're not concerned about this result for now. The main thing to remember here is that dy by dx times dx by dy is equal to 1. So the main idea here is to remember here that dy by dx times dx by dy simply gives us 1 here. Okay? And we can use this fact here to give us dx by dy. So therefore, dx by dy is simply given as 1 over dy by dx there. Okay? So that's the main thing that we're concerned about now for adapting to dx by dy. Moving on now to see how we use the chain rule. So let's say we're given a complex function here, f of x, okay? And we can write f of x here in the following form. So f of x is simply equal to g of h of x, okay? So if we can write f of x in this form, then we can apply the chain rule. And the chain rule is given as follows. So this is d f of x with respect to x here, dx. And this is equal now, using this fact here that f of x is equal to g of h of x, then we can simply replace f of x here with g of h of x. And doing so gives us the following result here. Okay, and in this case now, we can simply apply the chain rule to give the following result. Like we can see here, this is just our result for the chain rule. Okay, so that's our result for the chain rule. However, that might seem a little confusing. You may also see this given as y equals, so we may see this as, y equals g of u and u equals h of x. Okay, so u equals h of x, and therefore, again, applying the chain rule here, dy by dx is simply equal to dy by du times du over dx there. Okay, and that gives us our result there and shows us how to use the chain rule. And finally, moving on here to connecting rates of change. So we may see examples where there are several variables that might be linked. So for example, we could have distance, speed and acceleration. Or we could have length, surface area and volume. Now if you know the rate of change of one of these variables and the equation linking the variables, then we can simply use the chain rule to find the rates of change for the other variables. The big clue here is to watch out for the hidden derivatives given as words. So for example, words such as rate or per. So what we're looking out for here, so make sure to look out for words such as rate, so rate here, or per, okay? If you see these words here, that is a big clue within your question. Okay, and that's the basic idea there behind connecting rates of change. And that concludes this Maths Made Easy video on the chain rule.